So in this video we're going to have a look at Ecell and equilibrium. So we have an example equation here, which is hopefully a redox equation. So the first thing that you'll do when you get any equation is write the oxidation numbers. So silver solid is 0, oxygen is pure state 0, plus 1, plus 1, minus 2 for oxygen, and plus 1 for hydrogen. So no change in the hydrogen, but we do see oxygen being reduced, and we do see silver being oxidized. So I'm going to write out my expressions for Ag solid going to 4Ag plus 1 plus 4 electrons to balance that. That's my oxidation. So I need to have a pair. So everything else has got to be in the reduction side. So we see oxygen gas plus H plus, 4 of them, going to 2 moles of H2O liquid. So now what we'll do is we're going to have a look at the standard cell calculations. So E reduction standard state for silver plus 1. I'm just going to go to appendix E for it. So silver plus 1 is 0.799. 0.799 volts. Now we need to find the other one. Should probably add my 4 electrons in here. Just notice that wasn't there. So standard cell potential. We look it up, and we under oxygen plus 4 moles of H plus 4 electrons gives me 2 moles of H2O. That's exactly what we have. So that's equal to plus 1.23. So we have oxidation and reduction. So that means we have our anode and our cathode in this particular expression. So Ecell is equal to the reduction potential at the cathode minus the reduction potential at the anode. Ecell is equal to 1.23 volts minus 0.799 volts. So we'll do that calculation. 1.23 take away 0.799 equals 0.431 volts. So now that we have that, we can look at the Nernst equation. E equals Ecell. So it's non-standard is equal to standard minus 0.0592 over n log of, I'm going to write K here for a second. So when we look at this, we're going to have to set it up to reflect the change that we're doing. So when we have this expression, we should recognize where it comes from. plus RT, the natural logarithm of K. So we can use this particular expression for us. When we do this, we really are going to need a calculation for delta G at standard state. So we know that this is equal to 0. So this is equal to negative NFE plus RT ln K. NFE equals RT ln K. Cancel that out. And we end up with this expression NFE, which is delta G over RT, is equal to ln K. Now we can use this form and just plug in E. So let's start doing this. So we have 4 electrons being transferred using this equation here. 4 electrons times 96485 times 0.431 all over 8.314, assuming 298 Kelvin. We haven't really been told. Ln K. So we do our calculation. 4 times 96485 times 0.431 equals, divided by 8.314 times 298. So 67.1 equals ln K. Take the e to it. So 1.4 times 10 to the 29 is equal to K to this reaction. So for this particular reaction, what we're ending up doing and seeing is that we have a very, very product favored reaction.